the live button now. Okay, and I think we are live. Hi, everyone. Thank you again for joining another Virtual Jug session. Today, I'm very happy to have here with me Philip. Hi, Philip. How are you?
Hi, good. Well, I'm at home. It's comfy. The coffee is good. I'm kind of missing the crowd, but otherwise good.
Wonderful. Glad to hear that. So today, Philip's going to bring an interesting topic, and that's around on the bleeding edge of OpenTelemetry. I'm actually very excited to hear about that because I've been using OpenTracing for a while, and I know that OpenTracing has been moving to OpenTelemetry, right?
Yes. So let's see what happens, right?
Yeah, let's see what happens.
Because the topic is kind of confusing, but we'll dive into that.
Yeah, and then there is all the open sensors, OpenTelemetry, open sensors, OpenTracing, then OpenTelemetry. So it's kind of like a mess, and I hope that you can clarify us on that. Anyway, for people that are just joining us, and you haven't seen one of the virtual chat sessions before, feel free to join us on our Slack channel. So you can go to virtualjug.com. You'll get the link over there right on the top. You can join Slack and you can use it to post your questions to me, and I'll be happy to relay them back to Philip. If you prefer, you can also send whatever comment you have on your YouTube chat, and I'll also be monitoring that to relay that back to Philip. So without any further delay, Philip, please take the stage and good luck.
Yes, thanks. Let me share my screen and you will be my question proxy. So I'll wait for anything that comes up. So
wonderful.
Let's dive into on the bleeding edge of OpenTelemetry. So hi, I'm Philip. I work for Elastic, the company behind Elasticsearch, Kibana, Beats, Logstash. You might have seen us in that general monitoring or observability space. I will keep it pretty broad. Obviously, I will tie that a bit back to our products and what we do, but we will mostly focus on open standards and what they mean, how they fit together, what you can potentially use or not use today. So let's dive into that and see where it goes. Before I dive into like tracing, for example, in particular, I want to draw a bit the bigger or wider picture of what do we even do when we want to monitor or observe any system. Hopefully in production, we do that. So I assume that most of us are using logs in one way or another. They're just probably the most common approach because it's very easy to get started with any logging libraries. And what logs really are just chronological records of events. So when you run through some point in the code, some log statement will happen. And that's easy to understand and create. The kind of like big downside is that logs are very much on a component level. So you make that statement here, but especially if you have an application that is just not the monolith anymore, but more of a distributed system, piecing all the different logs together can be challenging. So that is kind of like the downside of what logs do, but they totally have their place and are one of the multiple tools in a general monitoring and observability space. Depending on what you're using for logging, potentially the ELK stack from us, this was before we added beats like the lightweight agent or shipper. So we only had 3 letters, E, L, and K. And well, we made the little colorful ELKs out of that. And that's what you get with them, which might nowadays look something like this. So for example, here, I kept it very simple. I have some web server I'm monitoring. I'm filtering down just to the Nginx logs. So this is a bit like a filter. Potentially, this is on multiple servers. So this will work across servers since this is all centralized. And I'm getting all the Nginx logs. And then within those, I have filtered for failed. So I'm just interested in where something failed. And you can see the little dots here. These are all the bad dots basically on the side. And I could also live stream that here. So that's like, it's a bit like tail F, but centralized, and you have more filtering capabilities. And that's what we do with logs. This is one common approach, not the only one, but just to point to what logs give you. Next up, what you then want to often do, and this is more of a general pointer to make your logs more useful, because sometimes I hear people say like, logs are nice, but they're not that useful. How do I make them more useful for my scenario? You often want to have more like event-like structures. So I'm using, this is a very simple Spring Boot security setup where I just have a login with Spring Security. And I have my log message, which was Philip failed to log in with password. This is kind of what you got from your classic log event. And potentially you had a log level and you had a timestamp for that. Maybe you even have a service name. So if you have many services, that might come in handy. But lower down here, I added some additional metadata. And this is kind of what sets logs and events apart, is that I have like a richer structure that I add here to let me figure out new questions. For example, I could figure out like, what is the ratio between login failures and successes? Which users fail to log in? Is it only Philip or is it many users? From which IP addresses are the requests coming? Is somebody trying to brute force my user accounts, or is it just random? So if you have these additional pieces of metadata, you will be able to answer questions that you were not able to answer before. Still, that is just logs. Logs alone don't give you a full overview of what is happening in your system. I assume that many of you are also using metrics, which, well, unsurprisingly, are a periodic measurement of some numeric KPI, like the availability of your service, the latency, maybe error rates. For that, you potentially use Prometheus, maybe. We do tie into that as well. So for example, you can throw in all your Prometheus endpoints. You can scrape them and throw them into our stack. There are multiple ways to do that. The general point about metrics is that metrics are very good at giving you an overview, like, is my service available? How fast is it? It's not very good normally at figuring out why. So, for example, if your service is slow, you see that it is slow, but it's very hard potentially to figure out why it is slow, or where that slowness, or that whatever is taking out your speed is coming from. So metrics are good for that overview. But then you might want to go back to the logs to see what is happening. But the logs, like I said, are more on that component level. So they're like more piecemeal. So it might sometimes be hard to figure out what is going on. Something that people then do oftentimes is also to measure uptime. The idea there is you don't just get metrics from like actual users failing, but you have something that checks your service. Is it working, like the pinger? So rather than having 20 users fail to reach your service, and then maybe you can see that in the metrics or in the logs, you have something that proactively actually does that for you, or that even runs a synthetic health check that might run through some common action. Maybe you use Pingdom for that. Our take on that looks something like this, where I run a pinger, for example, here in Frankfurt, and then I see this was the latency of my service, and this was how many requests were successful or unsuccessful. This could figure out, is my certificate expired, or when will it expire, etc. So the idea here is to not let users fail. So these three things are already useful, but they're still not the complete picture. Then there are traces, and I assume they're the least used, also because maybe they include kind of like most magic, and they're also potentially heavier to store because they contain so much information. So the idea here is that you get more context around your request. So rather than having the measurement for like the entire system, or a health check that sees is it working or not, or the log, which is like at this point in the code something happened, a trace is more on the request scope. So one user requests something, and then that request goes into your system, potentially touches multiple services, multiple databases. And at the end, you can reconstruct that request, and you can see, was that request successful or was it unsuccessful? And where did it spend its time? If it was slow, why was it slow, and where did it spend its time? So Jaeger and Zipkin are two very popular tools for that, which have their own agents, which you can include in your code. So you have an application-specific or programming language-specific agent that can extract that information, normally by giving each request a unique ID. And then you can basically follow that ID along and reconstruct the request based on these IDs. So the idea why you need tracing is to have more that request scope to see how are individual requests behaving for users and where is stuff happening. So all these 3 or 4 things played together, you still need logs to see what is happening at this point in the code. Metrics are good to get that overview. Health checks are good to figure out that stuff is failing before the user fails. Tracing is good to figure out for one specific request or a group of requests, because normally you will aggregate them. How fast or slow is something? How well is that working? Where is it failing? Where is it spending its time? Our take looks something like this, where I could figure out, am I spending time in the front-end rendering or in the application? How long does it take to service my requests? How many requests am I serving right now, etc. So let's dive more into that tracing concept, because we, like Ricardo mentioned, OpenTracing and then now OpenTelemetry, that already has the trace in the name. OpenTelemetry is not only about traces, but it's the most mature of the solutions in it. So let's look at what we have in that. So sometimes people call it application performance monitoring, or APM. Sometimes they call it tracing or distributed tracing. I will not make a big difference between the two. Some people say like APM is more the old school approach and distributed tracing is the new thing for microservices. As long as you have distributed tracing and you can follow requests throughout multiple services, we're all set here and it's pretty much all the same. The Wikipedia definition will tell you the monitoring and management of performance and availability of software applications. That is what tracing is, which might be correct, but doesn't tell you much. So let's see what we have here. So back in the days, we had something simple. We had my monolith and you had one version, and the monolith was generally working or it was not working. And like the request came in, you created your one database and you get a response back. It was pretty easy to figure out if it was working or not working. It was pretty easy to figure out, was it fast or slow? These were easier times. Nowadays, some people say these are now better times for vendors because you need a lot more tooling if you have these distributed systems, where your request comes in, then it runs wild between all the services, it touches multiple databases, and then at the end, some response comes back. If you just have metrics and maybe measure just what is the latency for my request, you might see the spike, but you will have a very hard time figuring out where does that latency come from. Or if you have errors, well, you see various log statements, but it's very hard to pinpoint for which requests, where did they run into an error and how did my systems behave overall if you cannot correlate those logs easily. And that is another thing where the tracing comes in. If you have that distributed tracing with the unique IDs per request and you attach those to your logs, you can then make much more sense of the logs for one request, even though it touches many services. If you have a central logging solution with that unique ID, you can then just follow the requests along and see how they work their way through the services, basically. Plus tracing to see overall, like, how is the behavior of this system. So that the goal of tracing in general is you want to have the transactional context. You want to be able to reconstruct those requests and then query and visualize and aggregate what is going on in them. Just for the terminology for tracing, generally the trace is a record of requests. It's like a directed acyclic graph. So request comes in and then it might touch multiple services and then it might combine again to give you the final answer at the end of the service. If it's very simple or if it's a monolith, it's more like in and out. If it's a distributed system, it might sprawl all over, then combine again and then get out, which is, of course, the much more interesting place to monitor anything. A span is a named and timed single operation, which can be nested. So it's like calling a method or calling something in your system. So it kind of like sprawls out into these individual spans, and all of the individual spans then make up that entire trace. There's also a span context, which means you ID the request, and you have the so-called context propagation, which basically means you have that ID that you carry along as the request works through your service. Those are the main terms that you need for tracing. The problem is generally if you use Jaeger, their header will look something like this. Or if you use the Elastic APM agent, their headers will look something like this. So they just look totally different and won't interoperate. So as long as you're using one single vendor for everything, that's cool. Their headers will work together. If you try to mix those vendors, you will have a problem. Also, the problem is, since you need language-specific agents, what happens if one system does not support one specific programming language? Maybe it doesn't have an agent for C++ if you still have that, or mobile agents, or it might not support like message queues like Kafka. So what do you do if one specific agent does not support everything? Do you need to switch out the vendor? It's kind of hard to figure out what will be supported and what you will need and pick the one single vendor that does everything right. So the idea there is that you have a vendor's agnostic or vendor neutral API for the tracing, and that was OpenTracing. So they basically standardized what the headers and like the naming conventions look like so that tools could interoperate. So here, this is just a nice visualization. You have the parent span. So this is what starts everything. This spans out into 2 child calls here. And it also calls another service which has another child span. And at the end, you will get the response back. So all of this is a single request. And then you have the parent span, and then you have the child request. Also nice, you see here are the individual log statements. And it's kind of like trying to tell you, well, these are on the component level. Like, yes, it is here, but it doesn't really show you the bigger picture of how this entire request behaved. So that's where tracing really comes in for that. Header looks something like this. So you have a so-called span context where you have a trace ID and the span ID. So this is like the entire request, and this is this subspan. You can have additional key value pairs for any metadata. Like if you want to have like a user ID, a shopping cart ID, whatever makes sense in your application, you can add that as a so-called baggage item, which is just key value pairs. The problem with OpenTracing is, or was, or whatever, is that it's really APIs or headers only. It does not specify like the wire protocol. So there are basically 2 wire protocols for tracing. One is in-band, and in-band is basically the propagation of those IDs. And then there's out-band, and out-band is basically all the individual services need to send their like collected data to a central place in the end. That's the out-band protocol. And OpenTracing supports neither of those. And that's why W3C created something called trace context. That is basically to specify the trace propagation within systems or across systems. Their standard looks like this. So it's called trace parent there. You have a version, trace ID, and a parent ID. So those pretty much map together. They look a bit different and are structurally a bit different, but they look, or you can correlate them to OpenTracing. It also supports baggage, or they call it correlation context, at least in the initial spec. So all of those are supported in W3 Trace context. And then you go one step further. So first you have the header, then you have the wire protocol, the in-band protocol to propagate. And now the kind of like next step is where OpenTelemetry comes in. It's an open source project. It's a CNCF sandbox protocol. And it goes beyond tracing. It also tries to include metrics and logs, though traces are the most mature of the solutions. And it does supersede both OpenTracing and OpenCensus, which was a Google implementation, which was also open source. And the thing about OpenTelemetry is that it tries to not only unify the wire protocols, but it also has OpenTelemetry agents. So rather than having a vendor-specific agent in your application, you have an OpenTelemetry generic agent that supports all of the tools. And it is widely supported by various vendors, including us, but many others as well. So it is generally vendor neutral, but ties into vendor solutions. So what you still need is you still have the visualization or the backend that stores the data that's still vendor specific. But like the collection of the data and sending it out, that is covered by OpenTelemetry. Some people, Adrian, he is the lead maintainer, I would say, of Zipkin, has a bit of a snarkier view on that, because he said like, well, OpenTracing always called itself basically a standard and never reached 1.0. Now we have open sensors that also never reached 1.0, and then you basically mix and mesh them together to have something new that hasn't had a stable release yet either. So with OpenTelemetry, we seem to be getting closer to finally getting a 1.0 release of something. So I don't want to be too negative here. For OpenTelemetry, there are 3 ways to integrate them in the backend tools or vendors. And a vendor can support one or multiple of those. So what do we have here? First thing is you have the agent in whatever programming language that you need to support. And then you could add in the agent, you could have a vendor exporter. So that would basically mean if the vendor wants to support this approach, for every single agent that is out there, they will need to implement their exporter that will speak their own via protocol and will talk to their backend solution, which is, of course, a lot of work because you need to support all the agents and keep your integration up to date with their development and have a pretty wide field to cover. So the overhead there is a bit larger. The next approach is interesting because it keeps all of this here vendor agnostic. So these are just OpenTelemetry agents. They speak the OpenTelemetry protocol. And then OpenTelemetry also provides one central tool, which is called the OpenTelemetry collector. And then you would need to implement a single exporter in this collector that then speaks your vendor protocol and talks to your solution. So all of this here is OpenTelemetry on like vendor agnostic. Only the exporter here, that is the only vendor specific thing. So switching out the vendor here is also pretty simple because you only need to basically reconfigure that exporter here if it's supported. And you can totally switch out the monitoring or observability solution that you're trying to use here. The final approach would be that the observability vendor implements the OpenTelemetry protocol directly. Then you could skip that OpenTelemetry collector component because here you need to run one additional component in the system that you otherwise wouldn't need. So this one here, the agents could just speak in their own protocol. So you only need to implement that protocol in that vendor-specific solution. And an OpenTelemetry solution could implement from any vendor, could implement 1, 2, or 3 of those approaches. You will just need to check what they support and how they do that. So how does Elastic integrate into that? So for now, to keep it simple, what we have done is we have the exporter in the OpenTelemetry collector. So in your applications, you just add the general OpenTelemetry agent. They will talk the OpenTelemetry protocol, talk to that collector, and then you just configure in the collector. You basically say where you want to forward that information in the Elastic stack. Our APM server will take that data and then store the final result in Elasticsearch, and then you could visualize it with Kibana, for example. Also, small side note, if you're using Jaeger and the Jaeger specific protocol, the Jaeger protocol we have already implemented. So if you have Jaeger agents here, you could just send the data from the Jaeger agents to here directly. If we will implement, for example, the OpenTelemetry protocol as a third protocol here, is still up for discussion. We're not sure, we haven't made the decision. For now, the only approach that we support is to use that Elastic exporter in the OpenTelemetry collector, forward it to our solution, and then that's it. We might add the protocol. If we will add the exporter in each of those agents, we are not sure because that will be even more work to do. So we will see. That is how you would, for example, configure the Jaeger intake on our side, but that's just as a small side note. So to run this, what I'm running here is we have the OpenTelemetry collector that I'm running. So this is using the collector. I'm using the Java agent. So OpenTelemetry Java instrumentation is where you can get the Java agent. And then this is the actual code sample that I'm running with the OpenTelemetry approach. This repository, by the way, has multiple approaches. So it uses a pure Elastic implementation. It shows how to use OpenTracing, and it has an OpenTelemetry implementation. So you could compare how the 3 can be set up and work together, or what the differences are between the 3, which is a nice way to compare them, just to make up your mind what is right for you. And at the end, I will also say a bit about like what might be a good approach right now and what are the trade-offs. By the way, just for the sake of generally how do agents work in Java? Java is kind of special or nicer than many other languages, I would say, because you can have this attached to a Java process for agents. So the three ways to start a Java application, or to kind of like the entry point into a Java application, are public static void main, what we use most of the time, but there is also pre-main and agent main. And that is, by the way, how most of the agents in the Java ecosystem do that. So which is nice, you have your general Spring Boot jar, for example, and that then only at runtime, you attach that agent jar to your own application, and they will kind of like use these other two entry points, or one of these other two entry points, to actually get into your application. Whereas in most other programming languages, you have a build dependency and you will need to instantiate any agent. So in Python, Ruby, etc., or JavaScript, or whatever, you need to instantiate the agent as a build dependency. In Java, you can keep it as a runtime dependency unless you want to instrument code specifically or manually yourself. We'll get into that a bit as well. I think .NET is the only language that has a similar concept, but if I'm not mistaken, only .NET Core supports that. So there you can also attach to an application. Whereas in most other programming languages, you need to instantiate the agent as a build dependency. And for example, Go is even more manual. There you need to basically wrap calls explicitly for an agent to support that. So how to actually do that here in my example, what I will be doing is I have my front-end application here, for example, at the bottom. And then what I do is I will add that Java agent. And what I'm running is I'm just using the OpenTelemetry Java agent. So this is not Elastic specific, nothing Elastic specific is even touching your application, not even as an agent. And then I'm just saying here, the endpoint, so the OpenTelemetry collector is running here, please forward that. And that's it. That's all the instrumentation you need to get going here. And then in the collector, you basically say, okay, you run here. That is what I've configured on the Java agent. And then this is, for example, the Elastic endpoint where to forward that information, or whatever other vendor you would use. Just in the exporters, you would just replace Elastic with whatever other vendor you want to place here. And then that's how you switch out that tooling in the background. And that's it. So I have a very simple application. I have a front-end application where it's like a little web shop. It has a fraud service, which will allow or deny me to buy something. Both of them are backed by a Postgres database. I have something that actually generates some traffic. All three of those Java applications are Spring Boot applications, and they will send their traces to OpenTelemetry, the collector here, that will export that to the Elastic stack and service here. So that's kind of like what I have set up. Timing wise, we're doing well, I guess. So what do we have here? I have, like I said, this is a very simple shop. It doesn't even really matter. I can buy products here. I can check out, and if I pay, okay. This is like, by default, it will deny it. Only if my anti-fraud service will send a success message, then it will actually accept me ordering this. And I think it's just a random number generator with some percentage that will reject larger transactions. That's basically all that is happening here. So what do we have running here? So if you've never seen, and let me refresh to see the current data. This is in Kibana. You have these different solutions. So for observability, we would have logs, metrics, and uptime as well, plus user experience, but I will only focus on tracing because with OpenTelemetry, that's the most mature solution. So what I'm doing here, let me find this, I think. Sorry, it's on the wrong screen. This is my Java code. And the only thing that I want to show you here really is if I run that, the only integration that I need here into OpenTelemetry by default would be here, where I run the Java agent when I start this. I do have it as a build dependency here as well, because I want to do some manual instrumentation. So what I have done in my Java application, and there is somewhere, so I have added OpenTelemetry as a build dependency here, because I want to add some manual instrumentation to that. What we are doing is basically I have some custom ID, the price, price range, country, the shipping method, etc. Those we want to add as explicit or extra attributes to our traces, basically. If you don't want to do that, you can just rely on like the automatic framework integration. For example, OpenTelemetry, the agent will know how to hack or how to figure out what is a JDBC connection, how does Spring Boot work and handle its requests, etc. But if you want to add any domain-specific attributes or knowledge, this is how you would do that. So I have added those here. And then in my order controller, if I would scroll further down somewhere here, I start my span, and then I just add those span attributes where I say, okay, the customer ID was this. So if you want to do that, obviously we'll need a build dependency. If you just want to rely on the auto instrumentation on the framework level, it's just a Java agent that you can rely on. So let's see what we have here. In my front-end application, you can see we have the load generator is running, and I'm not sure if you can hear my CPU, but with Zoom running and anything running locally, it's always almost killing my laptop. So you can see here, these are the response times for my service. So like I said, unlike logs or metrics, this is request scope. So I see both the metrics of like how long do the transactions take, how many am I serving, and what is, for example, the error rate. Time spent is currently only supported by our own Elastic agents, but not with the with the OpenTelemetry agent. So here you would see 20% of your time you spend in Spring Boot, and 30% in the front-end JavaScript library, and 50% in the database, for example. So you would have a breakdown how that works. And down here, you basically see the endpoints of how long do they take, how many and how many requests are they serving. So for example, here in orders, let's click on orders if my laptop is not melting. Come on. You can see for this specific endpoint, since this is request scope, this is just for that specific endpoint. You can see how that is doing. And you can also see we had 318 requests that took 100 to 200 milliseconds. But we also have a lot of requests that take around 1.1 to 1.2 seconds, and we had 500 of those. Those all created some transaction here. And down here, we can actually see where did we spend our time. So for example, I can click on the entire request. Come on, browser. I think my browser is dying. And then you can see this is all the data that we have collected for that request. So you can see the namespace we are running this in, the transaction ID, the headers that we have collected, the service name. So you can see this is the front-end service on staging. You might want to filter down to different environments with what we have collected, that the URL. We have not collected the user here since I did not log in, or you can see the user agent. All of that is collected, and you could then filter down to specific pieces of this. You can also see this is distributed tracing because it covers both our front end and our anti-fraud service, shown by the different colors. And you can also click on, I don't know, this specific request here that took 2.2 milliseconds. And that one will then show you the details for the SQL query that we were actually running here. So if you have anything that takes a long time, you could just figure out why maybe that is a bad SQL query, or whatever is happening here, or whatever method or system is being called, and where do you spend your time to figure out why is this currently so slow. And you can see the vast majority of the time we do spend in that fraud service. So the check order on the fraud service seems to be the bottleneck right here. And now we could dive into that fraud service to figure out like, why the fuck are you so slow? So you can see this is taking 99% of the total time of that request. And then we could dive into the details of that one. But I'll spare you the details since I don't want to keep you too long. If you have questions for anything of that, we can, of course, dive back into any of these. I've shown you the manual instrumentation. So what are your options? What can you use for tracing in general today? So we have Elastic APM specific agents, which have some more features also because they have been under development for a couple of years. So they have more features than what you get in OpenTelemetry. We've used them in production. They support metrics. They can report errors. They have more profiling capabilities. This one is Java specific. So they have some additional features, but they are vendor specific. So as long as you just add the -Java agent, maybe you don't care so much. If you start to instrument your code, well, pick your vendor wisely because replacing that instrumentation might be work afterwards. Though I think people are not yet sure if that is a bit like relational databases where you in theory could switch between them, but in practice you never do, or if for observability you will actually switch services, and that's a more common thing here. I don't think we kind of like the experience really tells that yet. The next option would be if you have any service that doesn't support or that our agents don't support, but that does support OpenTracing headers, you could use the Elastic agent with an OpenTracing bridge to actually work with those headers. So I know, for example, our agents did not support MongoDB requests or MongoDB queries, unlike relational database or JDBC queries in the past. For that, you had to fall back on the OpenTracing headers to actually see those and follow those along. Though we do support that for synchronous MongoDB queries now, not the async ones. So for that, you would still need the OpenTracing APIs. Then, if you have anything like Jaeger, for example, we have that protocol implemented, so that would allow an easy switch for that. If you want to do that, really depends. Where is OpenTelemetry in that mix? I don't want to be too harsh, but since there is no stable release yet, it's probably a bit more on the proof of concept phase still. The GA should be soon. I think initially the plan was to do that at KubeCon, but that they didn't make that, so it will be delayed, but it should be pretty soon to have a 1.0 of OpenTelemetry. Tracing is by far the most mature solution in that. Metrics are kind of like the next or the closest one after that, and logs are very early in the development process. So there is currently no good implementation for that, I think. And the metrics implementation is pretty close to what Prometheus is already doing, so that's not like a huge change. So to wrap up, I hope I made it clear why tracing, and so coming from why do you need logs and what are metrics and health checks, and why do you still need tracing to get that more complete picture, especially if you move beyond that good old monolith. I don't even want to bash the monolith because in terms of monitoring, it was much simpler. For us as vendors, distributed systems are much better though. And there you probably want open tracing or some form of tracing to actually follow on the request scope what is happening. Otherwise, you're just clueless. Standardization is sometimes tricky because there's so many and it's kind of confusing what is a standard and what is not. So OpenTracing is a standard. It has just been superseded by OpenTelemetry now. W3C Trace Context is also an open standard, and of course, OpenTelemetry is one as well. One that I didn't really mention yet so far is there is also a very new standard, OpenMetrics, which is mostly a standardization of the Prometheus protocol. And I think they started the release process for that 2 or 3 weeks ago only. And it is very close to what OpenTelemetry is doing. They just have some very small differences in naming conventions. So I think one of them allows underscores or numbers in the beginning of an attribute or a field name, whereas the other one doesn't. So there's some mapping to be done that's still spec'd out, but they are pretty similar otherwise. Jaeger, on the other hand, even though they sometimes kind of pretend they're a standard, is not a standard. It's an implementation that does open tracing, but it's just an implementation. It's not backed by or built on top of a standard. It is a CNCF project, but well, it's not a standard per se. That is basically our mapping to that entire kind of like area or landscape with logs, where to get or which logs to collect, which metrics to collect, the tracing data that you have, the uptime data, and then combining everything into one place. That is generally not just us, this is pretty much all the vendors out there. Everybody tries to have that single pane of glass, what they often call it, that you have one tool that supports everything, because you want to break out of those silos that you have metrics in one place and logs in one and traces in one, and then you need to jump between them and you cannot really make sense what is where. So that the big push in general, and OpenTelemetry totally kind of like fits that, is that you have one set of tools or one place where all the information comes together, because most of the information you get by kind of like combining it and getting the complete picture for that. And well, we and many others try to love OpenTelemetry because it tries to provide a leveling playing field on the collection side, and then still lets you kind of like build on the strength on the searching and aggregation and visualization side for within your solution. So while many try to level or kind of like standardize the agent side or the collection side, on the tool or like on the backend side or interaction side, then that's still very vendor driven. Okay. Everything I've shown you here was free. You can use it. I was running this on our cloud service. You can run it on-prem or on cloud. It doesn't really matter. So Elasticsearch and Kibana, where I showed you the traces, was on cloud. So all of this is out there, and well, use it to make the most of your production services. With that, thanks a lot. I mean, we can share the link afterwards. If you want to read the QR code, this is where you can get the slides, which are mostly up to date, I think, and that also links to the code and everything. So, do we have any questions? And I hope I did well on time.
No, that's fine. I mean, you have plenty of time left. So, I mean, and even if you took a little longer, I mean, we don't really have any session next, so we can always scratch a little bit. So no worries about it.
Yeah, I just know that kind of like the attendance of many people drops off dramatically after 45 minutes. So I try to not overburden you or me.
No, I mean, completely fine. So we have a question here from, I hope that I can pronounce this correctly, Ionel Sirbu. And he's asking, so rather than doing the manual instrumentation when we're doing the instrumentation over there on your demo, what about using log markers? That's how you add custom fields, right?
Yes. So, I mean, so yes, you can totally use log markers or MDC, the map diagnostic context in logging libraries. You can use those, and that is actually in the very beginning when I showed you how I went from logs to events, where I had like the failed and successful logins. I used MDC to get that information there. So I basically added those key value pairs through MDC logging. So that is totally true, but logging is not tracing, because logging again is on that component level. And yes, you will get that meta information and the key value pairs on that log event, but it's not on the trace itself. And also for Java, also kind of like in terms of build dependency, the log library that you use, probably SLF or J for the logging facade, that's a build dependency. So that's part of your code. And kind of like to add those key value pairs for tracing, you also have a build dependency. Then it's just an OpenTelemetry API that you need to add as a dependency. Whereas the auto instrumentation, well, that's just like on the framework agnostic one. I hope that makes sense.
Definitely, I think he does. So you went through a little bit on open sensors and open tracing, and when we get to OpenTelemetry. So what's your personal take on OpenTelemetry? Do you think that we finally have something that can see a 1.0 that's gonna fix some of the issues that we have with open sensors and open tracing, or do you believe that we still need to go a little bit further and improve the areas that are still lacking until we get to 1.0?
I think the plan is to come out with the 1.0 pretty soon, just to move past those historic problems of never reaching 1.0. Though what you call a 1.0 seems to be rather flexible, and I assume this is like the semantic versioning. So adding new features at any time is fine. Just you cannot break anything. So if you're happy with tracing in its current state and you release, that's fine. If you don't fully spec out metrics or logs, also fine, because you can just add a minor release or maybe some point a major release and just add more of those features as you go along. So like I said, tracing is by far the most mature one in OpenTelemetry. Also because it could build on more prior art with open tracing and open sensors. I think the other two will take more. Like metrics are probably the next one. Logs are, I don't know. I haven't seen anything that looks like ready for prime time in any way yet. And I just think just for the sake of getting a 1.0 out, there will be a 1.0 release pretty soon. If that actually makes it better or worse, is then up for discussion.
Okay, wonderful. So, and for developers out there, teams, products, applications that are already sitting on open sensors or open tracing, do you recommend them that they should move to OpenTelemetry, or what do you think that the migration path if they want to move to OpenTelemetry?
Yeah, that's a good point. So if you are not in, so if you're starting to develop, probably go with OpenTelemetry. I would say if you want to have like the vendor agnostic approach. If you have something that is working, I would kind of wait for a 1.0. Just in terms of like, I don't think that the APIs have any planned breaking changes still, but I mean it's a bit unsure. So I feel like if you're not under time pressure, maybe it's not the right point in time to migrate just yet. Maybe it's time to wait for that 1.0 and then make the jump. But of course, that's more of a personal feeling than like the final truth here.
Nicholas is asking, when are you going to answer his WhatsApp message?
I will after Nicolas A. Stop complaining. The French are always complaining. And yeah, I tried to not or only partially break my demo, so I will answer your message after that.
Okay, wonderful. Yeah, I don't think we have any more QA. Let me see if there is something more over here, but I don't believe there is. Well, without any further delay, then, if there is no more QA, I'm going to let you go. So thank you so much for coming up with this great presentation, and again for the great demos that you always perform to us. And you know, I believe that you actually our last session for the year, so you had this great honor to close 2020 for the VJUG.
It was my pleasure. Hope to see you next year or at some point in the future. Hopefully in person. Like when will JNation happen?
Well, JNation, we are targeting to do it in June as always, but I don't believe we're going to be able to do it on site. It's just that it's too much uncertain these days. And I know, I mean, even if we were going to, I mean, the situation might be better by June, and hopefully everyone is hoping that it is, right? But as you know, these conferences, they require several months in advance to be organized, right? And we cannot really, I mean, you don't even know what's going to happen next week, right? So it's kind of hard to actually plan something to happen in 6 months when you don't know if you're going to be locked down next week.
I'm very glad I'm not trying to organize any in-person event in the next couple of months or whatever, because I think before summer is just very tricky because there's so much uncertainty and so much planning
It
going
is,
into.
yes. So we most likely we're gonna do it online again. But if you have the chance, we might gonna try to do like a very small thing with maybe like 100 people or something like that, just to test the waters, you know.
I think like smaller more local events will be definitely the first to start, also because they're much easier to organize.
Yeah.
So I hope that like the meetups and everything in person will pick up again in the first half, and maybe in the second half we get more conferences. Well, fingers crossed.
Definitely. Okay, so Philip, thank you so much for joining us again. Thank you so much for all the VJUG members that watches this session, and especially all the ones that watches us for the entire 2020. It was like a rough year. So my wishes for everyone is that they stay safe, and hopefully we can get a better 2021 year. The VJUG is going to be here for us, so stay tuned for additional sessions. We're definitely going to have more content and more speakers to present to us on 2021. And so, without any further thing, I'll just like to wish you everyone on the VJUG a happy New Year. Bye bye.
Bye.